Hello everyone, we are going to solve some of the problems in the chapter 4 for exam 1. Okay, the first problem, problem 39, a car is moving at a speed with the velocity vc car and up the road perpendicular to the narrow river. A bridge across the river is approached by a boat floating with this velocity. Note that they are in the different directions. Car is moving, let's say this is the x and y directions, and along the y, okay, but the boat is along the minus x directions. At time t equal to 0, the car is at the bridge. The car is at the bridge as shown here, and the boat is at a distance 830 meters from the car. So from here to here is 830 meters, I should say. And the question is the time when the boat will be closest to the car. Find the time. We want to find the time when the boat will be closest to the car. That's the problem. So this is our natural language expression of our problem. So when the boat will be closest to the car. Okay, so in order to solve physics, we have to look at what are the given conditions. The car speed is along the road. VC is given this one. Boat speed along the river toward the bridge is given like this. The car is at the bridge and boat is given. Okay. Boat is given this way. The road is perpendicular to the river. So in this problem set, what we are going to concern is that let's change this one. So this is the x directions. Okay. And then let's assume that this is the y directions. Okay. And then the car positions is along the x. So xc is given by bct. Note that this is the kinematics for constant velocity, such that your displacement is described by the velocity. And then we note that car position at the t, it doesn't change, it doesn't move, it just stays at the y equal to 0, such as this one. So that at every position here, we have a x, t, and 0. Okay. And then the boat, you'll see that it does not move to the up and down. In other words, there is no x direction movement, so that xbt, boat position is 0, but ybt is given by at y code y at the time t equal to 0 is y0. It is y0. Okay. And then it's going to be decrease with this velocity minus bbt. That's the thing. So that we can find out at any time we have a xt 0 for this boat, and at the same time we have a 0 xbt. I'm sorry. No, I'm sorry. Xct, and this is ybt. Okay. And then the distance between these two positions is going to be designated r as a function of t, and then it is given by this vector minus this vector. Okay, so that we have this vector. And then it's given by this one. Okay. So we know what the YBT is. We know what the XCT is. Okay. So this is our coordinate, and then the distance, or L squared, is its components a square. Note that for arbitrary vector, let's say AX plus AX and AY, or even AZ, then you can have a magnitude squared is nothing but AX squared plus AY squared plus AG squared. So we are applying that rule here, so that the distance becomes the magnitude of the vector that connecting the boat and the car. Okay, this is R vector. Okay, and then R vector magnitude square is now we call it distance, and the distance is given as a function of t. So now distance is given as a function of t, but we need to know when the boat will be closest to the car. And then here comes a very important step. So when we say there's a minimum or maximum, we can find out the lesser dt t square t. Then we see that if it is a minimum, its gradient becomes 0. And also, if it is a maximum, you can find out its gradient is also 0. Okay, so if we have a certain function, so let's say a certain function as a function of t, and the maxima or minima conditions is 0. So note that this is the slope. Slope will be 0, and then means it is maxima or minima. So we take the derivative, and then we set it equal to 0 here. And then we have these equations, and then we have this one. And then we have, you'll see that we can have this time here, okay? And then plug in numbers, and then you'll see that VC, VB, and the VC square, V square, and then what's that is calculated, and the VB and Y0 has been calculated, and then you can find out seconds. Note that, once again, we need to check out the dimension. So velocity square is length divided by the time squared. And then here, the numerators, we have a length divided by the t, velocity, and then y0 is a length. So that you can see that L square t and L square over t square, then you can see that it's the time. Okay, in the dimensional analysis, this is the time. So it's a relevant answer. Okay, so now you know several language or several prompt for the physical solutions. The first thing is that you have this description into coordinate. Okay, coordinate. And the next thing is that the distance has been found out. Distance between the two objects, car and the boat. And then we are trying to find out minima. That means take the time derivative and set it equal to 0. simply because it will give you maxima or minima. But we'll see that if you look at it, yeah. So it's a kind of this type of quadratic functions, right? So that it should be minima, not the maxima. Okay, so that we know that if you take the derivative and set it equal to 0, then you will get the minimum. Okay. The next problem, to start an avalanche on a mountain slope, an artillery shell is fired with the initial velocity at an angle above the horizontal. It explodes on the mountain side 46 seconds after firing. What is the horizontal coordinate of the shell where it explodes relative its firing point? Okay, so what we are dealing with is two-dimensional motions. Okay, so let's X and Y. Okay, and then we have a certain angle and certain velocity, and then it will go over projectile motions. It's a projectile. So in other words, the shell will be under the influence of gravitational accelerations along along the vertical directions, but no force or accelerations along horizontal directions. So we have to separate motion along the horizontal direction and the vertical directions. So that's the first thing we need to find out. And note that along the vertical direction, there is always minus g acting on every position. But along the horizontal direction, there is no acceleration. That's the first thing we need to know. So let's try to find out what are the given initial velocity with the launch angle, and time to the explosion is 46 seconds. And we are going to assume that horizontal acceleration is 0. Okay, that's the very important things. So when you say it is a projectile, and then we are assuming two things: constant gravitational acceleration downward along the vertical directions, no acceleration along the horizontal directions. So that's the thing we need to keep in mind. And then what are the questions? What is the horizontal coordinate of the shells where it explodes relative to its firing point? Okay, so we need to find out, first of all, we need to separate the motions, two dimensions. So we have a V0x and V0y. Okay, V0x will not be changing because there is no acceleration. But the V0 will be affected by these gravitational accelerations. Okay, so that we should separate into vertical direction and horizontal directions. So for the horizontal directions, we have this, and we have this number here. And then we need to find out horizontal position after time t. So because there's no acceleration, position is given by V0x times t, right? It's the constant speed. And then we just plug in the 46 seconds here. And then you get this number. So key thing here is that you need to realize that it is under the projectile motion. And then we need to separate vertical motion and horizontal motions. And then look at the problem. What is being asked is a horizontal coordinate of shells. Okay, so that we are talking about horizontal positions. So we don't have to worry about how those velocity is going to change, but we just focus on a horizontal coordinate, which is given by this one. Okay. And then now a similar problem. To start an avalanche on a mountain slope, an artillery shell is fired with the initial velocity with an angle above horizontals. It explodes on the mountain 41 seconds after firing. What is the vertical distance? So now it's time to think about the vertical distance. So once again, we have to think about the V0, V0x, V0y. And then we need to note that the V0y along the vertical direction, there is a constant g. It's minus 9.8 meters per second squared. So that's the thing we need to think about. And then the question is about the vertical distance, how far it can go. So we need to find out what are given. The initial speed, launch angle, time to the explosion is time is given. And then we know that g is 9.8 meters per second. Even though it is not given, it is a general constant. We have to remember it. And then let's take out plus is the upward position along the y. And then we note that Vy is given by this one. Note that initially it is on the x equal to 0, y equal to 0. Okay. And then in that case, if we have a constant accelerations, and then you have a velocity times t plus acceleration times t squared, half of acceleration times t squared. And then we note that v0y is given by sine theta. Okay, so that we need to find out v0y initial vertical direction velocity is given by this number. And then we need to calculate two terms, this term and this term. So the first term, we know what the v0y is, and we know what the t is. T is given as 41 seconds. Okay, so we can find out the first term. And the second term is this one. Half over g gives you 4.9, and the t square is this one, and then you get this. So vertical distance is given by first term minus second term, and then it gives you this number. So it's about 2.56 times 10 to the 3 meter above its firing point. Okay. Once again, it is a projectile motion. During the firework display, a shell is shot into the air with an initial speed of 69 meters per second at an angle of 60 degrees. So theta is 60 degrees. And magnitude of velocity is given by this V0. The fuse is timed to ignite the shell just as it reaches the highest point above the ground. Calculate the height at which the shell explodes. So in other words, we need to find out the maximum height. Okay. So let's summarize what are given. Initial speed is given, launch angle is given, the gravitational acceleration is known. Shell explodes at the highest point we need to find out, we need to notice that at the vertical velocity is 0. Okay, so at the highest point, there's no upward or downward velocity. And then note that because it is under the constant influence of a gravitational force, so the velocity will decrease and then goes to 0 and then go back to the ground with a negative velocity. So we need to set up the equation for velocity along the vertical directions. So in order to find out the vertical initial velocity, we need to find out this component. And V0y is given by V0 times sine theta, and then we know that. And then use the kinematics to get the maximum height. We need to have a Vy equal to 0 at the maximum height. And we know that we have a equation that relates to the V square and distance s and the accelerations. So in other words, V square minus V, let's say final or initial square, is given by 2a acceleration times, let's say sf minus si. Okay, so this is the distance or this displacement, and this is the velocity. So we note that initial distance is given 0 along the horizontal directions, and we need to find out this distance. And then we know that a is given by minus g. Okay, so that if you set it up, then you have this equation for the motion of the shell along the vertical directions. So we note that Vy becomes 0 at the maximum height, and then we get this relationship such that Hmax is given by this one. We know what the V0y is, and we know what the G is, then you can calculate H. In a local cafe, a customer slides an empty mug down the counter for a refill. Then mug slides off the counter and then strikes the floor, xf equal to 1.49 meter, from the base of the counter. What is happening is that there is slides and then it falls, but it has an initial velocity, and then it is under the influence of a gravitational force. Once again, this is the projectile motion. Okay, it's under the influence of gravitational accelerations. Let's look at what is going to happen. What is the magnitude of a velocity? So it is trying to find out magnitude of velocity. So horizontal distance from the counter, we have a xf is given like this, and the counter is, height is given this, gravitation is this. So assume that mug slides up horizontally. So we note that initial vertical velocity is 0. There's no vertical velocity. Then its launch speed equals its horizontal speed. Okay. That means initially this whole speed will be only along this horizontal direction as is shown here. Okay. And then we need to figure out several things. First thing is the time to fall from the height yi. So know that we have a fixed height, and then the cup will fall to the floor or ground. Okay, so if you look at what is being asked, what is the magnitude of the velocity with which the mug left the counter? So we need to find out this velocity. Okay, so that's the important thing. So in order to find out, first we need to find out what it is available for us. First thing is that the height is given, and then is given in terms of this one. Note that there is no velocity along the vertical directions, so that we don't have a we have a zero initial velocity, right? And then we get this one, and then we have a time to fall. Okay. And then for the horizontal speed, same as the launch speed, that's what we want to have. And for the same time durations, it will travel along the xf, this much. For the given time, it will travel along this vertical direction, but at the same time, it will travel along this distance, xf. So that what we know is that along this x direction, there's no accelerations. Okay, so that what's going to happen here is that vx at the xf is given by v0x times t. Okay, that's the thing. Note that difference. Why? It is under the influence of a gravitational force, so that it is t square. But in the horizontal case, xf is nothing but v0x times t, linear in time with the velocity. And we know what the xf is, and now we know what the t is, such that we get have this one. And then initially there is no v0y, so that v0 is square root v0x squared plus v0y squared, so that this goes away, and then we get only v0x. Okay. Number 50, a rocket moves in the xy plane. The rocket's acceleration has a component about this x component and y component. And the alpha beta is given, and the gamma is also given. At t equal to 0, rocket is at the origin and has a velocity of this one. This is the initial velocity. Initial position, x0, y0 is origin. And then v0x and v0y is initial velocity. Okay. Calculate the position of the rocket along the vertical axis at t equal to 7 seconds. So we are confined into only the vertical directions, that means along the y. Okay. So let's try to think about what is going to happen. So ax along the horizontal directions, alpha t square. Along the vertical directions, we have this one. And we have this initial position and initial velocity. And the question is find out yt at t equal to 7 seconds. So we need to think about only the vertical directions, so that we don't need this information at all at this moment. So what we are going to do is that acceleration is given. So at is given, and then from yt is given, then we get the vyt, and then from the vyt we can find out yt. Okay, that's the step we are going to follow. So vyt is given by integration of ay with the initial y velocity. And then we get this formula. And then if you just plug in the beta and gamma, we get these equations. And then from Vt we get yt is given. So I just skipped. So yt is y0 plus v0 yt dt t equal to 0 to t. Okay. And then we know what the v0 yt here. I'm sorry, vy, not the v0y, it's the vy. So vy is given by previous case here. And then if you just integrate, then you have a 5t t square minus, okay, so that's the thing, t equal to 0 to t. Note that in this case, we have assumed that at t equal to 0, we have v0y. This is the case. And then x t equal to 0, y t equal to 0 is actually, if you look at it, is 0. Okay, so that we did not add yt equal to 0. Okay, and then we have, and if you put the t equal to 7 seconds, so then you can just use the formula here, and then you can calculate all the things, and then you get this distance. So to summarize what we have done, so if you look at the certain acceleration is given as a function of t, then with a certain initial conditions, x, let's say r0, and then v0, and then you can calculate v vector and from the plus v0, and then from this you can calculate the r is given by, this is not the vector, plus r0. Okay, so, and then you can calculate all the unknowns, velocity and the positions. The next problem. So once again, it is given such that component of acceleration, component of y component of acceleration is given. And then at t equal to 0, the initial condition is origin and the velocity. Okay. Find out how long it takes to return to the level of the ground y equal to 0. So if you look at it, there must be something happening. So note that we have a ay is given by this one, and then we are the assumption here is that how long it takes to return to the level of the ground y equal to 0. So that means under this acceleration, it is assuming, so initially it is y equal to 0, goes somewhere, and goes back to y equal to 0 once again, okay? So what we have to do is that just confine ourselves to the vertical position, okay? So that we will confine ourselves to the vertical component of accelerations. And then we note that t equal to 0, y0 is 0, and the initial velocity is given. We want the next time t is positive, is not equal to 0, when yt becomes 0. So that this is same as this one. So what we need to do is that from the, once again, acceleration is given, then we can find out the velocity by integral and putting the initial velocity there. And then we get these equations. And then from this, uh, once we have Vy, then we can find out the vertical position as a function of t, and then we get these equations. And then yt is given in this factorized form. So we need to set yt becomes 0, and then we note that t equal to 0 is one solution, but we don't want that. And we want a solution for these quadratic equations, right? And then solve the quadratic equations, and then we can find out the physically meaningful positions, such that if it becomes a negative, it doesn't mean anything. So we need only positive term, and then we should have a plus. If you take the minus, then it is a negative time. That means it happened earlier than the initial launch. So it's physically not meaningful. So we have only positive solution, and then this is the solution, and then this is what we want to have. Okay. So once again, it is A, B, and this case y, and then we set y equal to 0. Okay. That's the logic we followed. A fish swimming in the horizontal plane has a velocity in horizontal and vertical positions. After fish swims with a constant acceleration for 26 seconds, its velocity now becomes different. What is the magnitude of accelerations? Okay, so that's the thing we need to think about. Such that if you look at the initial velocity, we have both x and y component. Final velocity after t, we have a final velocity x and y coordinate. And then acceleration vector is given by final velocity minus initial velocity divided by the time it takes. Okay, so that each component along the x directions and along the y directions, and then we have this number, and this is the acceleration vector. And the magnitude of our acceleration is given by its component x square, y component square, and then you get this number. Okay. So basically, what this problem is trying to find out whether you understand the concept of acceleration. Acceleration is a change of velocity over time, elapsed time. Okay, so this is the important one. And then once again, you need to have a knowledge of a vector in coordinate. Okay, that is the key questions you should know. So now the 57, a particle starts from the origin. Once again, origin means both x, y is 0, initial position, with the initial velocity having an x component and y component, so that the initial velocity is given. The particle moves in the xy plane with the x component of the acceleration only. So only the x component will experience accelerations, and the ax is given by this one. Determine the distance from the origin at t equal to 6 seconds. So we have let's say, two cases, x and y. So initial position is given, x0 is 0, y0 is 0, and then you have a v0x and v0y. And then we have a separate motions, okay, so that as time goes by, we note that along the x direction, we have a constant accelerations. along the y direction, there is no accelerations. That's the thing we need to find out. So for the x coordinate, we have for the constant accelerations with the given initial position and the initial velocity, we have these equations. Okay, and if we plug in the t equal to 6, which is given, and then we get x6 is given by this one. And then along the y coordinate, we have said that there's no accelerations. So we have only these two terms. Y0 is given as 0, and the V0y is given minus 5 meter per second. Okay, so we just put here. And then we have a x and y coordinate. And then distance from the origin is given by the this magnitude equations. So once again, this problem will check out whether you know how to apply the kinematics for x direction and y directions, and then try to find out the magnitude of the distance from the coordinates. Okay. Okay, that's it. And I hope you understand, and then you will be well prepared for exam. Thank you.